All right, now let's start with Hess Law. So Hess Law basically states that the energy change or the overall enthalpy change. So let's see what this means. This means, or what is this law? It says that the overall enthalpy change, enthalpy is energy, right? So the overall enthalpy change of a reaction is independent of the route taken. So Hess's law says that the overall enthalpy change of a reaction is independent of the route taken. For example, if you are on ground floor and you go on to the third floor, so if you go from ground floor to third floor directly, your energy will be, let's say, E, right? When you go from ground to third. Or if you go from ground to first, then from first to second, and then from second to third, it's the same thing. Your energy would still be E, right? So it's irrespective of what route you take. Either you go directly or you go by multiple steps. It does not matter. The energy would be the same. So whether you go from one end to the other end directly, or you go from the one end to intermediates and then to the end, the energy change would be equal. And why is that? Because energy cannot be created nor destroyed. So first law of thermodynamics says that if you go to, from example, let's just see this example one right here. So you have A and you have D. So let's say this is your starting point and this is your end point. So you can go from A to D directly. And let's call this delta H1. All right. So this right here is your delta H1. Then you can go from A to B. And then you can go from B to C. And then from C to D. Let's call this delta H2. Let's call this delta H3. Let's call this delta H4. Right? Now you see your starting point is A. And your end point is D. You can go from the start to the end directly. Or you can go from start to this intermediate, then to this intermediate, then here. The energy change would be equal or same. So can I say, what is the start? We are starting from A. What is the end? D. The rest of them are intermediates. So you can go from start to end directly. And what's the energy for that? Delta H1. So you can say delta H1 will be equal to what? Start to intermediate, that is delta H2. And then another intermediate, that is delta H3. Then another intermediate, delta H4. Is this clear? So you can go from one end to the other end directly or go in multiple steps. Hess law says that it is independent of the route taken, the energy change would be the same. Clear? Let's see another example. You have A, let's say you're going from A to C, A to B, C to B. Now, can you identify where we are starting from? A. We are starting from A. So can I call this my start? Where are we ending? B. Do you all understand why we are ending at B? Because you see, you're not ending at C. Because if you were ending at C, this arrow would have been from B to C. Do you understand that? So everything must end up at B, and that it is. You see, A is also directly going to B. A is going to C, which is also coming back to B. So your end point is what? B. So your start is A, and your end point is what? B. And therefore your C is what? Intermediate. Let's call this delta H1. Let's call this delta H2. Let's call this delta H3. So according to Hess law, you can go from the start to end directly. So you can go from the start to the end directly, which will be equal to what? Start to intermediate and then to end. What is your value from start to end? The value is delta H2. So you will say delta H2, which will be equal to, what is start to intermediate? Delta H1. And what is intermediate to end? Delta H3. So Hess law basically says that the energy change of going to the reactant to the product directly or going in multiple steps, either way, it will be equal. Clear? Now, let's take an example. We have calcium carbonate giving you calcium oxide plus carbon dioxide. They want you to find this delta HR. They have given you all of this information. They have given you formation of calcium carbonate as A kilojoules per mole, formation of calcium oxide as B, formation of carbon dioxide as C. Now you need to calculate delta H. Yesterday we saw a method of how to calculate delta H using enthalpy changes of formation. And what was our formula? Enthalpy change of reaction is equal to formation of product minus formation of reactant. So our first method is to use that formula. Delta HR is equals to formation of products minus formation of reactants. Yeah, and this method works really well when you have to do MCQs. So if you see that formation is given to you and you need to calculate delta H, you can do it directly. And what will be the direct method? Formation of product minus formation of reactants. That's it. Even if they say use an energy cycle to find your answer, you don't really have to do that for MCQs because they really can't see your working, right? So you can just directly do this method and find your delta H, given that all the formations are given to you. Yes? Clear? So let's see, what will be the delta H for this? It would be delta HR. What is the formation of products? So calcium oxide, the value for that is B, plus carbon dioxide, that is C, minus calcium carbonate, that is A. Is this clear? So this is your first method, which we have seen yesterday. All right. Now, if any of these guys had 2 moles, what would we have done? We would have multiplied these values by 2 because we know formation is per mole. It is for 1 mole. Clear? Now let's move on to our second method. Our second method is the Hess cycle. So every time they say draw an energy cycle, they basically mean the Hess cycle, right? And Hess cycle is based on which law? Hess's law. What is the Hess's law? That you can go directly or you can go indirectly. The energy change would be equal, right? Now let's see how we use the Hess's cycle to find delta H. Now, this is relatively more time consuming and I want you guys to just listen for now. You guys can copy later. All right. So let's see how we draw the Hess cycle. Now, there are multiple steps that you have to follow. The first step is that you need to write the equations of everything that is given to you. All right. So the first step is write equations for the data provided. So what is the data that is provided to us? We've been given formation of calcium carbonate, formation of calcium oxide, formation of carbon dioxide. Can we write equations for this? Do we know how to write equations for formation? Yes. What is formation? 1 mole of something being formed from its constituent elements in their standard state and the standard conditions. So let's see how will we write their equations. So how will you write the equation for formation of calcium carbonate? It should be formed how much? 1 mole. From its constituent elements, which are calcium solid plus carbon solid plus oxygen gas. Let's balance this. So calcium is balanced, carbon is balanced, oxygen is 3 moles in the product side. On the product side, so we will put a 3/2. Clear? Next up, calcium oxide. How will we write down the formation of calcium oxide? Calcium solid plus oxygen gas, and this would be half O2. We balance it. Formation of carbon dioxide, that would be 1 mole being formed from carbon solid, oxygen gas. So the first step is whatever is given to you, you need to write down the equations for that. Very often they also, instead of giving you this, they will tell you find the enthalpy change of formation of something, or maybe like, and we'll see questions. Sometimes this equation is also not given to you and they give you a terminology by which you have to figure out the equation. Like they can say, find the formation of calcium carbonate or something. Not in this case, it won't apply. Anyway, let's just move ahead, and when we get to those questions, I will explain. So right here, first step is to write down the equations for everything which we've written, right? The second step is to make 3 boxes, right? So the first step is write down the equations of everything that's given to you. The second step is to make 3 boxes. In those 3 boxes, the equation, the most complicated equation, or what you need to find, that goes in the first 2 boxes. So what needs to be found, so what you need to calculate goes in the first 2 boxes. Sometimes if this doesn't work, you can also take the most complicated equation in the first 2 boxes. So let's make the 3 boxes. Let's follow step 2 now. So step 2 is making 3 boxes. This is box number 1, box number 2, box number 3. So you've made 3 boxes. Let me label them 1, 2, 3. Then whatever you need to find, that goes in the first 2 boxes. What do we need to find? We need to find this delta HR. This will go where? In the first 2 boxes. How will we put this equation in the first 2 boxes? The reactant in the first box, the product in the second box. So calcium carbonate comes here. And this is calcium oxide plus carbon dioxide. And this is what you need to find. Can I call this X? Can I just call this X? We need to find this X. Do you see? I have put the equation that I need to find in the first 2 boxes. Reactant in the first box, product in the second box. Clear? So this is your third step. The fourth step is all other equations that you have made, they go in the third box. So all the remaining equations, they go in the third box. So we've already put this, all the remaining equations means these equations. Where do you got to put them? In the third box. Now everyone look here, how will we put them in the third box? Now you have to put all 3 of them in the third box. Let's see how. Let me start with this one. Carbon plus oxygen giving carbon dioxide. So it is carbon plus oxygen giving what? Carbon dioxide. Do you see carbon dioxide is in the second box? So carbon plus oxygen giving carbon dioxide. Do you understand? The arrow will go from carbon to oxygen to carbon dioxide like this. Clear? So we've put this equation, right? We've put this equation in the third box. Now let's put this one. Calcium plus oxygen giving calcium oxide. So right here, I'm going to write calcium. Oxygen is already here, so you don't need to rewrite it. Now you'll be like, but miss, what about the moles? They won't be balanced. It doesn't matter because these elements are used to make this, used to make this, and used to make this. So their moles are endless. Doesn't really matter. You don't really need to balance it. If you want to, that's up to you, but you don't need to. Now you'll be like, oh miss, so 1 mole of oxygen was needed for this, half a mole is needed for this. So should I add like a 2.5 over here? No, you don't really have to. That won't change your answer, won't do anything. All right. So you know it's calcium. Oxygen was already written. You don't really need to bother again. And this makes calcium oxide. Clear? So we've put the second equation as well. Now let's put this last one. Calcium plus carbon plus oxygen making what? Calcium carbonate. You already have calcium. You already have carbon. You already have oxygen. And they are making what? Calcium carbonate. Is this clear? Now let's write the values for all these arrows. Formation of calcium carbonate was A kilojoules per mole. So can I say this value is A? Formation of calcium carbonate was A. Formation of calcium oxide is B. And formation of this is C. Clear? Now, we've done up till the fourth step. The fifth step is determine the start and end of the reaction. So determine the start and determine the end of the reaction. So let's see how we do that. Now, you see this is an arrow right here. This is called an arrowhead. This is called the tail. So wherever you have maximum heads, that will be your end box. And whichever box has maximum tails, that will be your start. All right. So you got to determine your end and your start. Whichever has maximum heads, arrowheads, that will be your end. Whichever has maximum tails would be your start. Do you see? You have a tail on this box, 3 tails. So can I say box number 3 will be your start? Right? Now, wherever you have maximum heads, where do you have maximum heads? 1, 2, 3 on box number 2. So here you have maximum heads. So this becomes your end. And therefore 1 would be your intermediate. Clear? And then your 6th step is, you should know start to end you can go directly, which will be equal to what? Start to intermediate to end, because that's what Hess's law tells you. And that's based on law of thermodynamics, that whether you do it in one go or you do it in multiple steps, the energy change would be equal. Clear? So that's your 6th step. Start to end. What is the value from start to end? What are the values of energy? B and C. So can I say it would be B plus C, which is equal to, what is start to intermediate? A. And what is intermediate to end? Intermediate to end is X. That's what we need to find. And if I simplify this, X will be equal to what? X will be equal to B plus C minus A. Do you see? It's the same equation that you got here. Do you see that? The one that we got from the direct method, that was also what? B plus C minus A. This is also what? B plus C minus A. Right? But when they ask you to show the energy cycle, you have to show the Hess cycle. It's a little tedious and we'll practice a lot, don't worry. But do you understand this? Do you all get it? So this is how we make the Hessis cycle. All right? Clear? All right. We're not practicing questions on Hess cycle right now. Let's introduce another energy change called standard enthalpy change of combustion. What have we done so far? We've done enthalpy change of formation. Now we will see enthalpy change of combustion. What is combustion? What is combustion? Burning of something in oxygen. So now let's define standard enthalpy change of combustion. Because it's enthalpy change is why we have delta H. Since the conditions are standard is why we put a phi. And combustion is why we have a C. Clear? Let's define this. What is standard enthalpy change of combustion? So standard enthalpy change of combustion is the energy released. Now, if we say energy released, what does that tell you? That this will always be exothermic. Formation was energy change. That meant it could be exo or endo. This is exothermic, is why we are using the term energy released. So this is the energy released when 1 mole of a substance burns completely or undergoes complete combustion. So burns completely, or you can say undergoes complete combustion under standard conditions. And what are the standard conditions? 1 atm pressure and 25 degrees Celsius temperature. So what is enthalpy change of combustion? It is the energy released, implying that it will always be Exothermic, when 1 mole of something burns completely under standard conditions. Clear? Let's see. So we know that this will always be what? Exothermic. Clear? Energy is always released in combustion. Now let's see how we write down the equation for combustion. What was happening in formation? 1 mole of something was formed, right? Now in combustion, 1 mole of something burns, and they burn in oxygen. Let's see. So you have CH4, that's your first example. So whatever is burning now must be how many moles? 1 mole. So this must be how much? 1 mole. It burns in what? Oxygen. And you know that this is undergoing complete combustion. Do you see right here? It says burns completely. What are the products of complete combustion? Carbon dioxide and water. When a hydrocarbon burns in oxygen completely, it gives you what? Carbon dioxide and water. Do you remember doing the equation CXHY plus X plus Y upon 4O2, etc.? So this would give you what? It would give you carbon dioxide and water. Now let's balance this. So you get carbon dioxide and water. Now carbon is already balanced. You have 4 hydrogen here, so you put a 2 here. You have 2 and 2, 4 oxygens here, so you will put a 2 here. Clear? And this right here becomes what? Combustion of methane. So this right here will be called what? Enthalpy change of combustion of methane. Clear? Let's see combustion of carbon. How will we write that? It will be carbon plus oxygen, giving you carbon dioxide. That's it. Now this won't give you water because there is no hydrogen on the reactant side. Is this clear? And this will be called what? Enthalpy change of combustion of carbon. Can I also call this what? Can I call this enthalpy change of formation of carbon dioxide? Can I call this that? Yes, because what was formation of carbon dioxide? 1 mole of carbon dioxide being formed from its constituent elements in their standard state. So can I say this equation can interchangeably be used for combustion of carbon and formation of carbon dioxide? And how many moles of carbon should we have? 1 mole. Clear? Can you guys try these? Can you try the rest? Can you write down the equation for combustion of these? 1 second. The equations now. So hydrogen with oxygen will give you what? Water. So hydrogen burning would be 1 mole giving you H2O, and this would be half a mole of O2. Can I call this combustion of hydrogen? Can I also call this what? Formation of water. Yeah. Let's see the next one. Sulfur. So you have 1 mole of sulfur burning in oxygen, giving what? Sulfur dioxide. Now you can't get carbon dioxide and water here. You understand that? There is no carbon, no hydrogen in the reactant. So this would be called what? Combustion of sulfur. Or you can also call this what? Formation of sulfur dioxide. Right? Now you have ethanol, C2H5OH. So this burns in oxygen. Will give you what? Carbon dioxide and water. Let's balance this. How many carbons do we have here? 2. So let's put a 2 here. How many hydrogens? 6. So we put a 3 here. 2 2s are 4, 5, 6, 7 oxygens here. So let's put a 3 here. 3 2s are 6 and 1, 7. Very often when you are balancing these equations for combustion, you tend to miss out on this oxygen. Right? Please don't. All right. So this right here is combustion of ethanol. Let's see combustion of ethanoic acid. This would be oxygen giving what? Carbon dioxide and water. Now let's balance it. How many carbons here? 2. How many hydrogens here? 4. How many oxygens? 2. 2s are 4, 5 and 6. So what will we put here? 2. Because 2 2s are 4, 5 and 6. This right here becomes combustion of ethanoic acid. C2H4, let's write the combustion of this. So that would be 1 mole of this burning in oxygen to give carbon dioxide and water. How many carbons? 2. How many hydrogens? 4. So you put a 2 here, and then how many oxygens? 2 2s are 4, 5, 6. So let's put a 3 here. Is this clear? This is how you write the equations for combustion. All right. Now, if you remember, formations, I told you, for elements in their pure form were 0, right? Let's see combustion of oxygen. What will be combustion of oxygen? Oxygen burning in oxygen to give you more oxygen. Is there any change in reactant or product? No, so there is no energy change. Therefore, combustion would be 0. So combustion of oxygen would be 0. Likewise, carbon dioxide burning in oxygen will just give you more carbon dioxide. Will there be any change? No. Therefore, combustion of carbon dioxide would also be what? 0. Water burning in oxygen will just give you more H2O. So this would be what? Also 0. So just like elements in their elemental form had 0 formation, these guys have 0 combustion, right? Now, if you remember, I told you delta H could be calculated by multiple ways. One was bond energy, which we did in bonding. The other was formation, which we did yesterday. You can also use enthalpy change of combustion to find delta H. Let's see how. So we can use enthalpy change of combustion to find delta H. So delta HR will be equal to combustion of reactants minus combustion of products. What was formation? Product minus reactant. What is combustion? Reactant minus product. Now, it sometimes gets really confusing and overwhelming because you're just like bond broken, bond formed, that was product reactant. Like we don't understand it. We don't remember it. So I'll tell you a way to remember it. For bond energies, just remember it's always bonds broken minus bonds formed. That's why I don't really use reactant and product there, right? Is why I prefer you guys practicing it this way, that it would be bonds broken minus bonds formed. And bonds broken are always of the reactant, bonds formed are always of the product. When you are using enthalpy change of formation to find delta H, now what happens in formation? What is the essence of the reaction? Something is being formed. And what is that something? Product. So whatever you are doing in the reaction, which is forming the product, that comes first. So it will be formation of product minus formation of reactant. Now, what do you do in combustion? You burn something. And what are you burning? The reactant. So what is the essence of the reaction? Burning of the reactant. So the reactant will come first. So when you want to calculate delta H, you will do reactant, combustion of reactant minus combustion of products. And when you want to use formation, you will say formation of product minus formation of reactants. Is that clear? Any questions?